let's quickly understand how to calculate percentage excess air. So, let's take the numerical example based on this as a combustion reactor is fed with 50 kmol per hour of butane and 2100 kmol per hour of air. Calculate the percentage excess air used. So, let's solve it. So to solve it, let's take basis as 50 kmol per hour of butane. Then given that butane flow rate is equal to 50 kmol per hour and air flow rate is equal to 2100 kmol per hour. Then we have to calculate percentage excess air. So first, let's write the balanced reaction as C4H10 plus 13 by 2O2 gives 4CO2 plus 5H2O. Then we know that the formula for percentage excess air as percentage excess air is equal to air supplied minus air theoretically required divided by air theoretical required into 100. So to calculate percentage excess air, first we need to calculate air supplied and then theoretically required air. So now, first let's calculate air supplied. So as we know we have already given, air flow rate in the feed is equal to 2100 kmol per hour. So we have first term as air supplied is equal to 2100 kmol per hour. Now let's calculate theoretically required air. So as we know, the formula for theoretically required air as theoretically required air is equal to theoretically required oxygen divided by 0.21. So to calculate theoretically required air, first we need to calculate theoretically required oxygen. So from balance reaction, we can easily find out theoretically required oxygen using stoichiometry requirement concept. So, from reaction, we can say that 1 kmol of C4H10 required 13 by 2, that is 6.5 kmol of O2, which means that 6.5 kmol of oxygen is required for the combustion of 1 kmol C4H10. But we have given combustion reactor is fed with 50 kmol per hour of butane. Hence let's calculate required oxygen for 50 kmol per hour butane. Hence from stoichiometric relation concept, we can calculate theoretical O2 requirement for 50 kmol butane is equal to 6.5 divided by 1 into 50. So after solving we get theoretical required O2 is equal to 325 kmol per hour. In this way we get theoretical required O2. So now let's calculate theoretical required air. So after putting the value of theoretical required O2 in the formula of theoretical required air, we get theoretically required air is equal to 325 divided by 0.21. After solving this we get theoretically required air is equal to 1547.6 kmol per hour. In this way we can calculate both terms, that is, air supplied and theoretically required air. Now let's put both values in the formula of percentage excess air. So after putting the values, we get percentage excess air is equal to 2100 minus 1547.6 divided by 1547.6 into 100. So after calculating, we get percentage excess air is equal to 35.7%.